Hello and welcome to the final video in my current VTOL Basics series. Now again, this has been filmed with the very kind help and support of Ben up at 3DXR. Ben's business is building and training people on massive UAV systems, lots of which are VTOL based at the moment. So he has a huge amount of experience. He is a Jedi master at this stuff, and he has been incredibly generous with his time, giving up 2 business days to basically create these videos with me. So a big thank you to Ben for doing that. And not only does he do that, 3DXR also sell lots of stuff that the rest of us in the hobby use on a regular basis. So I'll put a link down below, so go and check out his store. Now, if you've been watching the series so far, thank you for sticking with it. You've made it to the end. Last time we talked about the different flight modes and how Ben sets it up and the process for the maiden flight. It's not really a maiden flight. This is a model that he flies regularly, but he agreed to kind of fly it and go through the process as though it was a maiden flight so that we can kind of learn the tips and tricks of how he does it. Again, the Ardu pilot documentation for quad plane is always the place to go to have a look at this. So again, massive thank you to Ben. Let's go over to him in the field and we'll watch how it works. Just be aware the audio in this next clip is recorded from the hat cam. I didn't want to have him mic'd up with extra radio signals and everything else going around. So the audio isn't as good as I would normally do on one of my videos, but you can still hear what Ben is saying and what's going on.
We've arrived at the field. We've set up our glorious takeoff mat. We've physically assembled the drone, so we've put together all the connecting parts, the wings, the tails on this, which have quick release connectors. So mechanically everything's connected. The batteries are connected, it's powered on, and also we've checked the center of gravity. So whenever I set the center of gravity, we're even for level to slightly nose down, never tail heavy. You must address that, and in this case we don't have the payload, which is a mapping camera. So the batteries in this case are quite far back, but it's neutrally balanced for the center of gravity. Because this drone has been on the table for our video, previously it had been at the other end of the country, it's been taken a bit, put together. The first thing I want to do now for our sort of pseudo maiden is to do a motor test. So the simple motor test commanded for a mission planner. So we are all connected to the drone. We're using a Wi-Fi hotspot to connect to mission planner. This could be with, if you don't use a Heelink, if you're using a traditional radio such as the Taranis or the Radio Master, you might also have a telemetry radio, so that could be a 868 or a 433 radio, and that allows you to have a connection to mission planner in the field. So let's have a little look here on the main screen. Because we're using a Heelink, we have got video. We're also getting live data, so we've got our battery data. Our values are moving, so there's a little bit of wind here, so we're getting airspeed movements. And so this is, we are connected to the drone. So I want to carry out the motor test, which is in the setup page, optional hardware, motor test. This is a quad plane, so it's got 4 motors, A, B, C, and D in this case. So starting at the front right and going clockwise. So we're going to test motor A. Okay, spinning in the right direction and it works, that's the main thing. B, so again we're going clockwise around the clock. C, D. So what I was wanting to know there is if there'd been any sort of damage to the wiring that we haven't picked up in the physical examination of the aircraft. So the motors are spinning, they're starting at the same point, they're going to correct direction. Next we want to check the control surfaces. Now we're in quad plane hover, that is my default starting mode. I can test the controls here, but it's in a quad plane mode. There's no rudder and the controls are sort of minimized. So what I need to do is I need to test this in a manual fixed wing mode. Now that is a dangerous mode to have a switch assigned to for a new person. Because changing into manual fixed wing mode from a quad plane mode would instantly stop the motors. So I need manual mode here to test them. So I'm going to just command that from the ground station. So from the action tab, I can select some flight modes. So it's highlighted auto. If I now select manual and press set mode, we've had the feedback from the transmitter, it's in manual, and I can tell instantly because the rudder works. it's moving the right direction. We've got full elevator control and everything's moving correctly. So that's responding correctly to inputs. During the setup stage, we did test that it responds correctly to movements of the plane in a stabilized mode. So we know that's okay as well, and none of those settings have been adjusted. So we're in manual mode, that's being commanded from the ground station. So I need to get it back into a quad mode so I can press it here. We never did any of that while we're armed. The motors are safe, there's no throttle input. It's purely testing control surfaces. So let's have a little look here. The next step in this maiden, the pseudo maiden, would be in stabilized, Q stabilized, okay? I didn't want this on a switch because on a finished aircraft, be it a product or built for a customer, I don't want a user to go into Q stabilized by accident. So you have to select it from the computer, or I could go into the drop down menu. So we're in Q stabilized. The reason why we don't put that in the final plane is because if somebody switches to that instead of Q hover or Q loiter, Q stabilize is much more sort of aggressive to stick inputs, but also the throttle is a percentage throttle, so it will not be level. It could climb, it could descend, and that could be quite rapid. So it's not a mode I want a user to go into accidentally. So we haven't got on a switch, but we can get this in several different ways from here or from the computer. So this is a mode where I would hover it, I would look for vibrations, oscillations, and I would make sure the plane's responding to the controls. So depending on the size of your drone, it could be, it's very different to a multi-rotor because you have the large wing, and depending how windy it is, it's going to be more susceptible to being blown around. So we're in Q stabilized, we've got a green light so it will arm. So the first thing I like to do, whether it's a VTOL or a copter, is make sure arming and disarming is working. So let's have a look here. To arm it, and the motors are going to spin, I'm not going to raise the throttle, I'm just going to disarm. It takes a few seconds. So it's good to get a feel for that in case, you know, if ever when you're testing a new aircraft, anything you can do to avoid sort of panic or unknown, it's a good step. So I'm happy arming and disarming works. The next thing we can do, we can arm it, and we can try and see if stick inputs are working before it takes off. So if I go right, I can see and I can hear little changes in the motors. So that's a good start before I go foot off the ground. So because we're in stabilized, I need to sort of get it up a little bit, and I'm very cautious to catch it. So it is going, and I'm just trying to get it sort of steady. So okay, we don't really have any bad oscillations. We'll get a bit out of ground. It's responding correctly. I'm just going to plonk it back on the H. Looks about right, and I'll just stop it down. So the vibrations on that looked fine. This has had some tuning prior. It moved in the correct direction to the sticks. We are pointing into the wind just to minimise that sort of weather veining naturally, and we're getting a little bit of sort of buffering here from the wind coming in. In stabilised, yeah, you could spend a little bit more time. For the purpose of the video, I'm now going to switch into Q hover, and I'm going to see it hold its altitude but not position. So I'm still going to have to maintain its position. So I imagine I'm going to have to push it that way into the wind. So let's do the same again. We're going to arm it, and what I'll do this time, I'm going to take it a bit higher. So in this case, I must raise the stick, and I'll release. And this is hover, so it's blowing that way. I now need to sort of readjust what the centre is, so I need to move it into the wind. So if I let go, it will start to drift with the wind. There we go, see it moving? So it's holding height, but it's getting blown around. So let's readjust it, and let's get it back over there. Now, as the vehicle gets bigger, this is 2.4 meters, it is more susceptible to wind. It's pretty steady, but if the wind was higher, I would expect it to be, you know, taking a bit of a battering. It would be, wings would be dipping a bit, and you know, you would hear it more struggle. We have got a wind speed today of about 4 or 5 meters a second, so it's just requiring a little moderate sort of holding, but it's doing pretty well. So in this mode, this is equivalent to alt hold in a copter. The throttle will go up. If I release it, it'll level out, but it is going to drift the wind, so I'm just going to hold it. Needs a little bit of yawing to correct it, but that is Q hover. If I change it into Q lighter now, so I'm just going to put it a little bit further away from the vehicle. It's a long press on this remote. Now this is hands off, and it will hold its position. So that is a, you know, that's the GPS mode for VTOL, is Q lighter. If I move it and let go, it'll brake and hold its position. Okay, we also mentioned a mode, prop assist. On this one it's set to come on, I think, at 8 meters. So we're reading 6 meters now. Let's see what happens if we increase the height. 7 meters. We've just gone past the 8 meter mark. Maybe it's 10. There we go. 10 meters I must have set it to. So the front propeller's come on. It's not going anywhere. It's just keeping the plane more level in flight. So it's nice and flat. And if I reduce the height, this front motor will turn off. So let's see there. 10 meters, and now it's off. 9.5, there we go. Front motor's turned off. You must be careful having prop assist on if you're taking off and landing different heights. So this has caught me out before. If I went to the top corner of the field, where I think it's about 12 meters higher, what could happen is, as I come down to the ground, it still thinks it needs prop assist. So just be careful of that. The way to fix that will be to have a LiDAR on, so that it knows the actual height above the ground, and Q assist and prop assist will stop correctly. So that is it as a copter in lighter, holding its position. And we had Q hover, where it's going to drift. So let's see there, I've gone into Q hover. Now the wind is going to blow us. I must interact. Okay. And what I'll do is I'm just going to land it. Sometimes landing it in Q hover compared to Q lighter is easier. That's just about, you know, it's physically a big aircraft, so it's a bit jerky in a GPS mode. And disarming it. Keep it there.
Disarmed.
Disarm. Yeah. So that's testing it as a quad plane. We've gone through initially Q stabilize just for that little testing. You could have done that a bit longer, and you could have dialed in a few more settings. We then progressed to Q hover, which is the altitude holding mode. So we're able to set an altitude, and then we would just be moved by the wind. So I had to counteract that to keep it in the same place. And then we saw Q loiter, which is a GPS holding mode, where you can take your hands off and it'll sit there. Obviously, if there was a stronger wind, it would lean over a bit more. Once we got above the height, in this case of 10 meters, that was when prop assist came on. So the front motor turned on to help it stay pointing into the wind at a level plane without normally having to lean into the wind, where you have sort of excessive multi-rotor use on the rear motors, or vice versa, depending which way it's facing. The next step to do will be to test a transition. So what we'll do for the purpose of this demonstration will be to invoke a transition by going from a quad mode, a Q mode, into an airplane mode, and then we'll quickly abort it just to show you, how you can test this and see what happens. We'll get to a safe altitude of about 30 meters. Once you're all set up and sort of up and running and familiar with it, you might want to reduce that. But for this aircraft, that is the normal sort of height, 30 meters. Sometimes I'll even go 40 meters depending on the sort of trees nearby and you know, the rest of the conditions, the amount of wind, if I think the transition needs a bit longer. So what we're in now, we're in Q hover. For the purpose of the video, I'm going to do this in loiter, and that is just so that we can talk about it. So we're in quad loiter. We'll arm the plane. We're going to punch it up. I'm going to put it to the side, so I'm going to that tree, and I'm going to climb up to 30 meters. There's our assistance. 20 meters. Okay, that's probably okay for this video. So we're sitting there in Q loiter. What I'll do is I'm going to put it into fly-by-wire, just B for the purpose of this video, but I'm going to very quickly put it back into a Q mode. So long press on this one. It's going forward, and I'm going to take it back now. So it's started to transition. It hasn't fully transitioned because the motor never cut off, and now it's transitioned back into Q loiter, and it's sat there as a copter. And we've got the front motor is on now, just in a holding bit. So that was sort of seeing what happens. That was very close to that. A few more seconds, that would have just been gone. So that was a sort of a practice transition. I know this one flies, so let's continue on with it. So let's go back into B, long press, and it's going to transition again now. The wind has picked up a bit, so ground speed is 18 meters a second now. Looks good, airspeed 18. We are a plane. And this one is, it looks slow, it's just a big plane. I can gain some height in B mode, so let's lift up. 35 meters, 45 meters, 50 meters. And I'm going to keep it about 60 meters for the purpose of the video, just so you can see it better. Normally, this drone always flies at about 120 meters because it's doing a mapping mission with a high resolution camera. So I'll keep it low and bring it as close as I can to get it better in video. It is front motor only. The propellers on the VTOL motors on the wings are free to spin around, but quite often they do just sit stationary. They might end up lining up forward, but it's very rare to see them windmilling. And this now in the B mode will basically aim for its cruise speed, and it will just fly around like that. There you have it. So that is it in B mode. And what I'm going to show you now is, so if this was a maiden, what I would need to do now is to calibrate the airspeed sensor. So I'm going to gain some altitude, just get it up to around 100 meter mark. I'm going to put it above us, and then I'm going to engage loiter mode. So this isn't Q loiter, this is a fixed wing loiter mode. So we're at 90 meters now, 100 meters. I'm going to bring it back, and I'll engage loiter roughly above that tree, so that'll become the center of the circle. I know where the tree is. So what I'm going to do now, press loiter. That's the center of the circle. It's going to go out to the perimeter, then it's going to start doing its circle. And that is loiter as a fixed wing, so it's circling around a GPS point. If we were to look at the laptop, we'll start to see a perfect circle that then you could fly. We're connected to it. There we go. Look at our little snail trail there, and it's forming a circle now. And the parameter we would adjust now would be airspeed auto calibration. So let's have a look at that. Config, you can do this in flight, full parameter list. So here's our ratio at the minute is 1.85. That's the parameter that we should change. So full parameter list, ARS to start off airspeed. Airspeed autocal is currently 0. Let's change that to 1 and invoke the calibration. We must write it. So airspeed, this is a parameter you can do in flight. Yes, for sure. The parameter is saved. Let's have a look back on the main screen on our quick actions tab. Now what I've done here is I've added this by double clicking, and and I select the one I want. So here we've got airspeed ratio. Now this has been done, so we might not see a change, but what should happen is we might see this number start to go up a little bit or down a bit. And this particular airspeed sensor is it's a Matek DLVR airspeed sensor, and all the ones I've built have been about the 1.85 mark. So prior to its first flight, I would type that parameter in, and then I would do the calibration flight. So it's just changed there to 1.84. Just this will depend on the sensor and also the way you've done your tube and the pitot that you've used. Other sensors like the 4525 are often around 1.45 for the ratio I've found, but it does depend how the person uses the tube and how they've done their build. So I'm quite happy this is a good reading. So what I'd do is, once I'd completed about 5 minutes of circling, I can go back in and I can turn that parameter off. So I want to turn it off because I don't want that left on by mistake.
Which parameter is that?
So that's airspeed auto cal. So any changes made to the ratio will have been saved. So let's leave that now. It's ended up pretty much where it was. So yeah, about 5 minutes of circling. The other thing we can do, which we'll show you, is auto tuning as a plane. So let's do that. Auto tune is a flight mode, and on a VTOL we have Q auto tune, which is a multi-rotor, so definitely don't want to press that button. And we have auto tune, which is a fixed wing auto tune. Because you just do this in the setup process, we don't need a permanent mode button for it, but you could temporarily assign a button, or, as we've seen before, we can change flight modes from within Mission Planner, or the drop down on Q ground control on here. So we have auto tune highlighted, but I haven't pressed it. We'll start off by doing, we'll do the roll for this demonstration, and we want to go, we need nice long runs where I'm going to input maximum stick deflection left and right, taking about a second to do each one. So let's put it in a position that we like. So I'm going to switch it back into fly-by-wire B and take manual control. I'm going to point it down the field, and I'm going to invoke auto tune now.
Auto tune flight mode.
Full stick deflection, full stick deflection. This takes about 2 up and downs, and it's going to tell us, it's going to announce when it's complete. So I'm holding it till it goes all the way, holding it all the way, all the way, all the way. Once I've hit my safe distance.
0.0105.
So it's done the roll D. That's quite good. I'm not putting in any pitch or nothing intentionally. I can bring it back to faces because that's just sort of leaving my visual line there. So let's bring it back and let's continue this until it says complete. If it's been taking a while and it hasn't announced complete.
0.2647. Roll finished.
That's it. That's roll done. So let's put it back into a flight mode. This is a good reason to have loiter as well, because look, I need to change some settings. So we can let it circle now. So what we did there was we've basically tuned the roll. It's pretty quick. Even on all the planes I've done it to since version 4.1 of the firmware, it's very quick. Normally 2 lines, you know, up and down or left and right. The next step would to do the pitch. Now the pitch, you rarely pitch up and down with full stick deflection. You must make sure everything is secure in the aircraft. Your batteries are strapped down, everything is nicely restrained, or you could do some damage. So let's do the pitch. Once it's in a favourable position, I'll take manual control. So I'm going to flick it in to fly-by-wire B, point it where I want it to be, and press auto tune now.
Auto tune flight mode.
So we're going to do the pitch. Now the pitch is quite restricted on this aircraft to about plus or minus 20 degrees. What I want to be careful of as well is not either losing or gaining too much height.
0.0137.
It's very quick.
Pitch P.
And that's basically the pitch done.
473. Pitch finished. finished.
Okay.
Lighter flight mode.
So what I've done there is I've just put it into lighter flight mode. So we're approaching our sort of limit we're allowed to go to. Let's have a look at one other mode, RTL. Will it work? What do you reckon, Lee?
I'm pretty confident about this. However,
Yeah?
it'll be a lovely way to finish the video.
Let's see. I'm going to press RTL.
Return to launch flight mode.
So it's facing us. It's coming straight back as a plane. I set an RTL height, which I believe is 40 meters on this one. So it's going to come down and descend. I have tweaked, because I have tested this before, I have tweaked a parameter which is how long it takes to slow down. Now we are heading downwind, so an overshoot, might happen, but let's see what it should do. So it should engage the quad motors.
Return to launch flight mode.
There we go. And it's weather vaning and prop assisting. Will it land better than me? And this is all so I am not touching it at all. It is correcting itself. And it'll disarm after a few seconds. What might be happening now is it's actually sitting on the end of the mat, so it wasn't level. So that was an RTL where it flew back as a fixed wing. It engaged the quad motors, and then it came down. As it got lower to the ground, it did reposition, so that was all by itself, and it's landed, pretty well for a failsafe. So what's really nice about the VTOL plane firmware since version 4.1 is RTL, where you don't have to do any pre-planning. You can just press a button, set the height. So that one did come back at 50 meters sorry this time. Ideally that should have been lower. It would have probably been more accurate and less bumpy, but transitioning to a lower height, and it has landed within this oversized takeoff mat quite well.
So there we have it. We've come to the end of the first VTOL series. I hope you have learnt as much as I have watching Ben impart some of his wisdom and knowledge about how you build these things, what the important things to consider are, how you set it up, install it into the craft, the commissioning, the setup for maidening and the maiden flight as well. I feel as though I'm ready to make my own one of these, and I've got in a Pixhawk Cube Orange and some other pieces so that I can closely approximate for my first adventure into building a VTOL myself what Ben was doing on the desk. And then once I've got my head around how that all works, then we can kind of look at how we shrink that down to smaller and smaller models that would fit in a backpack. So join me in that next series when I start it, where we'll take all of this fantastic stuff that Ben has shared with us and put it into practice, building one from scratch. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organized into easy to follow playlists that, if you're trying to learn a topic, will take you from the basics right the way through to some pretty advanced stuff.